My distinguished viewers, it's nice seeing you once again because you are doing great. And if it's your first time of watching our video, I will actually want you to subscribe so that we can update you because we are in for a serious business here. And now today, we want to talk about the expressions of equation using dimensions. And here is a very much classical questions before us. This is one of the examinations question that was presented before us. The velocity of a wave in a stretched string depends on the tension. That factors they are talking about here, while the velocity, the tension T in the spring, and the mass per unit length represented as what mu of the spring. Yes. Obtain an expression for V in terms of T and mu using the method of dimension. So we are expected to use dimension to solve this question. Now, how do we express this equation? Now we have the velocity V, then we have the tension depends or proportional to the what? The tension T, and mass per unit length, which is represented by what? The mu. So we can now say V is equal to K T, then the mu, where K is what? Constant. Yes, the K is a constant proportionality. But don't forget that this mu is represented by what? They call it mass per unit what? Length. So which is M over L length. So which can be written as what? M L minus 1. And don't forget we also have the tension. Tension is same thing as force in a spring, or force acting on that spring, which is what? Mass times what? Acceleration, which is what? M. Acceleration is what? The dimension is LT minus 2. If you are not familiar with this, we have done how to estimate the dimension for acceleration in our previous video. Please, you can go back and check. Now, we also have the last of all, the velocity. Velocity is what? The dimension is LT minus y. But then, for us to be able to evaluate this properly, we need to do what? We need to label the variables. Velocity is depending on the tension, let me call it x, and the mu, which is mass per unit, let me call it y. So what is the dimension for velocity? Dimension for velocity is what? LT minus 1. So LT minus 1 is equal to K. Then T is what? Which is the tension, which was M LT minus 2 raised to power. Don't forget x. Then we have the mu. This mu is not y. The mu, which is what? ML minus 1. ML. Let me write it properly. This is equal to LT minus 1. ML minus 1. Then what the power is? Raised to power what? Y. So now we can now separate the variables so that we can be able to evaluate them. So then we are going to have LT minus 1 is equal to what? K. Or better still, let me come up. LT minus 1 is equal to what? K. Yes, LT minus 1. T minus 1 is equal to K. Then let us open the bracket. You have mx. M raised by the x. Then the L also raised by the x. Then the T minus 2 raised by x. T minus 2, at least minus 2 times s to give us minus 2x. And then we also have we're also going to open this one, which is going to be what? The M raised by what? Y. Then the L raised by minus y. So now, at the end of the day, we are going to have LT minus 1 is equal to K M X L. Let's call it like terms, please. Remember, this constant case is constant. It has no issue with other variables. So those with m's, let them come together. Those with l, let them come together. Those with t, let them. So this is m raised by x, m raised by y. So we go to dot m raised by y. Then we have the l dot lx raised by times l raised by minus y. Then this one is left with dot t minus 2x. So So at the end of the day, it's going to be what? LT minus 1 is equal to, let me remove the k for now, but we are going to introduce it again. M raised to power. We take the common power according to indices. We common base, we add the power x plus y dot common power L. We add common base, add the power x plus minus y, because times in indices you add the power when the base is times. So plus x plus minus y equals minus y dot t raised to minus 2x. So now remember, this L is having a variable outside this t. So equating it now, how can we represent this m now? Let us represent this m by saying m raised to power 0. Remember, m raised to power 0 is 1. So we have m raised to power 0, l t minus 1. So as the variable can be equated properly, so that's why I represent by 0, because m raised to power 0 is 1. It also means nothing. So it's equal to what? M raised to power x plus y dot l raised to minus x raised to minus y dot t raised to minus 2x. So now let's equate all the variables. So m raised to power 0 is equal to m raised to power x plus y. Then l raised to power 1 is equal to what? L raised to power x minus y. Then t raised to power minus 1 is equal to what? T raised to power minus 1 is equal to what? T raised to power minus 2x. So what happens? The m cancel the m, the l will cancel the l, the t will cancel the t. So we are left with what? 0 is equal to what? 0 is equal to what? X plus y. Let's call this equation 1. Then the next one we are left with what? 1. Remember this l is power 1. Yes, from this l is power 1. When it cancels each other, it becomes 1 is equal to what? X minus y equation 2. Then next one we have the t has cancelled each other. The value left is what? Minus 1. So we have minus 1 is equal to what? Minus 2x equation 3. Yes. So now let's start from equation 3 because it's only one variable needed here now. So the value is at minus 2. We are going to have from equation 3 now we have minus 1 divided by minus 2 is equal to what? X. So we have x is equal to what? 1 over 2. Now let's substitute this 1 over 2 for x in equation 1. Substitute. Substitute 1 over 2 for x in equation 1. So coming back to equation 1 now, we're having 1 over 2 plus y is equal to what? Is 0. So y is equal to what? Minus 1 over 2. So there's no need of having our equation 2 again because we've gotten our x and y. So x is equal to what? 1 over 2. Y is equal to what? Minus 1 over 2. So let's come back and substitute this into the what? Into the equation. We have v is equal to k. K what? T raised by x and the mu raised by what? Y. So what is x now? X is 1 over 2. So we have v is equal to k T raised by 1 over 2. Then the mu now, which is what? Minus 1 over 2. Mu raised by minus 1 over 2. So let us take it to the former square root form. As 1 over 2 in this is 1 over is square root. So we're having v is equal to what? V is equal to what? K. This t will remain at the top, square root. Or let me do it such that you understand. T raised by 1 over 2, 1 over 2, all over the mu. The mu raised by what? 1 over 2. Why? Because of this minus sign. It is inverse. So it goes down. So at the end of the day, 1 over 2 is square root. We're going to have v k square root what? T all over the mu. So that's the answer. So the correct expression for this now, we can write it as v is equal to what? K square root T over mu. Answer. So that's the dimension expression for this kind of a question. Just to understand how to analyze dimension. Once you understand how to analyze dimension, you'll be able to break it down, understand indices, and it's very simple. I hope you enjoyed the video. Please place your comments if you're having issues, and don't forget to subscribe, like, and share with your friends. See you in our next video, as there are a lot of questions for us to solve. Love you and have a nice day. But before we go, I want to make sure you note that this is the final answer. Yes, I just have to write this so that you can understand. Thank you guys. Love you.